So the first thing we're going to talk about is domain and range of a function. Before we even do that, though, can anyone tell me what a function is or what a relation is? What's a relation in math? Maybe give me an example of a relation or a function. What does a relation mean in English? Like if you're talking about a relation of yours. Kind of an old-fashioned word, actually. But you might say, my relations live in Ontario. What does that mean? Yeah, sorry, did someone have their hand up? No? You guys are just being shy today? So in English, a relation is an old-fashioned word for someone you're related to, right? Like a relative, okay? In math, a relation is a connection between two variables, sometimes more, but often two, particularly in high school math. So anything that you might graph like on an XY plane is considered a relation. A function is a specific type of relation where each input into the function only has one output, okay? But for example, there's a relationship between, let's say, smoking and lung cancer. How much you smoke and your chance of getting lung cancer. So those are two different variables. There is a connection, a relationship, an association between the two. And there's my phone call. Sorry, guys. All right, so in math, we study relations and functions, and we study connections between two variables, and in science as well, because really we want to see if there's a trend that's going on, and we can figure out what that trend is, perhaps use a mathematical equation to model that trend, and then we can make predictions about what's happening between these two variables, right? And so the applications of relations and functions are just endless. And relations and functions specifically are kind of organized into different families that all behave the same way. So one of those families that you would have looked at in Math 10C are linear functions, which look like lines. And then in grade 11, depending on what course you took, you maybe would have looked at different ones. I know some of you took 20-1 and some of you took 20-2. I know in both courses for sure you would have looked at quadratic functions, which look like that, parabolas, okay? And we're going to look at a variety of different functions in this course as well, and just kind of study what are their properties, what makes one different than the other, that sort of thing. And then, of course, also, what real-life situations can we model with these particular types of relations or functions, okay? Domain and range. So the domain and range of a function are the values that make sense for either the input of the function or the output of the function. Okay, the domain is the input, the range is the output. So for example, if I said, we're going to look at a connection or an association or a relationship between the date in second semester and the number of students who are present in Math 30-2, okay? Then the input is the date. So the dates that would make sense, the values that would make sense for the domain would be anywhere from February 1st to June 30th inclusive, because those are the dates that second semester happens. The range of that function would be, well, what's the lowest number of students that could be in this course, in class on any given day? Even lower, 0. Yeah, you guys could all be absent one day. Hopefully that won't happen. And then the maximum number of people that are here, I think there are 33 people on my class list. So that would go up to 33, anywhere from 0 to 33. Okay, that would be the range or the output. Okay, now we are going to be talking a lot about domains and ranges of various different types of functions. And also when we have an application, when we're looking at a specific situation, sometimes those can be limited. But really what I want to review today is how do we write them out? what's the notation that we use? How do we communicate with it, what a domain and range is? And then as we get into more and more of the coursework, we'll sort of look at how that works in various types of relations and functions. Okay? So domain. Domain is a set of values that can be inputted into a function or relation. The range is the set of output values. Okay. There are two main ways that we communicate domain and range. One of them is called set notation. The other one is called interval notation. Okay. In like a Math 30-1 or Math 20-1, the expectation is that you know both. In this course, you only need to know set notation. However, you can, of course, use interval notation if you want as well. Okay? When you're looking at domain and range graphically, because the example that we just talked about with number of students in class on any given day is more sort of like an oral explanation, your domain, the input, is along the horizontal axis. It's your x-axis, or sometimes if it's an application, it'll be called a different variable. Your range is your y-axis or your vertical axis. So when you're looking at a graph and you're trying to determine the domain and range, there's a couple of things that you want to be aware of. The first one is arrows, because an arrow indicates that that function or relation is going to continue in that direction forever. And sometimes arrows can go in, actually usually they go both in a vertical and horizontal direction. So in this case, we have an arrow here, and in fact, this one is only going left. Okay, so here's an arrow. It's going left. It does not go up or down. Okay, along the x-axis, that means the function goes to the left forever. Okay, there's an arrow here as well that goes right, and that's also horizontal. And so the function goes right forever. And this entire thing is continuous or connected. And so what I've just drawn along the axis is essentially a graph of what the domain is. And it's everything. X can be anything, or the domain is that X is an element of the real numbers. Okay? This is sort of the notation that's acceptable. It's not full set notation. The full set notation would be this. The domain is the set of X such that X is an element of the real numbers. Okay? But for this course, the first one is fine. As long as you can recognize that, if you were to see that on an assessment, for example, and you know what that means, that's fine. You don't have to write out the full set notation. Okay? Now, if we look vertically, there is no arrow going up or down. And so there has to be a highest value and a lowest value. And that's going to give us our range. So if I look at my lowest value vertically, that's over here. And my highest value is here. And so essentially my range is anywhere from -1 to 1 inclusive, because it includes those values. Okay? When your range or your domain is sort of sandwiched in between two numbers, we can use something called a double inequality to express that. And so the lowest value is -1. That's less than or equal to y, which is less than or equal to 1. Okay, so hopefully that sparks a memory from previous math courses. Okay? I always tell people, though, because people always mess up or forget which way the inequalities go, it always looks like this. Minimum on the left, maximum on the right, variable in the middle, x or y, it depends on which one, and the inequalities point towards the minimum. They both point the same way, and it's towards the minimum. Okay? Sometimes these are just less than rather than less than or equal to. We're going to actually see that. Oh, we're not going to see that in this example, but I'll talk about it, okay? If it's just less than, it means that that end value is not part of the domain and range, okay? Any questions so far? All right, let's look at this one. So there are no arrows on this example. What that means is that for the domain, there's got to be, and domain is horizontal, there's got to be a leftmost point and a rightmost point. And for the range, there's got to be a lowest point and a highest point. Okay? So you really, really want to try and split the graph up into horizontal values and vertical values and look at those one at a time. And I really like to use the axis to help me do that. So if I'm looking at the leftmost value, that happens right here. And this dot is colored in. Sometimes you'll see those dots are like hollow. That means that if it's hollow, that point isn't included. And that's an example of where you just use a less than rather than a less than or equal to. Okay? The rightmost point is right here. Okay? That's my domain. When I'm looking at my range, there's going to be a lowest and a highest point. Sometimes those aren't the end points. So my lowest point happens right here. That's at -2. And my highest point, it's not actually the end point, it's up here, happens right here. That's at 2. So that's my range. Okay? Once you identify it, you just have to write it out using the right notation. So for our domain here, domain goes from -4 to -1. So my domain is, the minimum is on the left, -4. Maximum is on the right, -1. The variable in this case is x. And the less than or equal to point to the left. They point towards the minimum. That's my domain. Okay? For my range, similar sort of pattern. My minimum value is -2. My maximum value is 2. My variable is y. And there we go. Okay? Questions with that so far? Awesome. Okay? Now, C is another example, which brings something up that I forgot to mention, which I usually mention off the top. And that is that when you look at a graph, you are looking at a very small, tiny little snapshot of the coordinate plane, which is infinite. Okay? And what that means is that if you get a graph that goes off the page, like this, with no dot on the end, you need to assume that there's an arrow and that goes on forever. Okay? So put arrows in here. It is only an endpoint if you see a dot. Okay? Now, if we look horizontally, actually, let's just take these arrows one at a time. This arrow actually goes in 2 directions. It goes in a horizontal direction and it goes in a vertical direction. Okay? Horizontally, it's going left. Vertically, it's going down. This arrow horizontally is going right, and vertically is going up. Okay, now everything in between is connected, so I can sort of connect these arrowheads. And essentially, what we can see is that both domain and range is that either variable can be anything. Okay? Now, how do we express that? The domain is that x is an element of the real numbers, and the range is that y is an element of the real numbers. Okay? Questions with that so far? All right, cool. So I'm going to give you guys maybe 5 minutes to try these 3 yourself, and then we will keep going. I want to talk about the first one. So the range for the first one is great, but this graph does go off the page, and it's not going entirely vertical, okay? It's definitely increasing more vertically than it is horizontally because it's a pretty steep curve, but it does slightly go to the right. Okay, so yes, it's going up, but it's also going to the right. And this one also is slightly going down. No, it's not slightly going down. It's really going down. It's slightly going left, okay? So in fact, the domain and range are both variables are elements of the real numbers, okay? One thing that I saw people do is that they looked at the intercepts and chose that to be the domain. That is not correct, okay? Because if you said that there are no x values to the left of this point, well, what about all these ones down here? Okay, so we do look at intercepts for certain things. We do not look at them for domain and range, at least not as a rule of thumb. Okay, so just make sure that you're aware of that. These two are really good. Okay, intercepts. Okay, so we're going to talk about intercepts next. Intercepts are the values where the graph hits each axis. Okay, so essentially intercepts are hits or crosses each axis. Okay, yes?
Start recording again?
Yep.
Okay.
Keeping me on my toes. Okay. Did I? Now I'm second guessing myself. Hold on a sec. Yeah, it's going. All right. So one thing that is important to keep in mind about intercepts is this. Okay. When you're looking at a y-intercept, you're on the y-axis. If you are on the y-axis and you're thinking about a coordinate point, you actually know the value of one of the coordinates. Okay? Think about a coordinate point as being like brackets x, y. Everywhere on the y-axis, one of those things is the same. Which one is the same and what is it? Yeah. Right. Everywhere on the y-axis, horizontally, you're at 0. Similarly, everywhere on, or I think I said horizontal, everywhere on the vertical axis, horizontally, you're at 0. Everywhere on the horizontal axis, vertically, you're at 0. So everywhere along the y-axis, x is 0. If you know the value of the y-intercept, you know the x-coordinate as well. It is 0. Okay? In my opinion, intercepts are incredibly undervalued resource. They tell us a lot of information. One thing that's important to remember, though, is that on the y-axis, x is 0. And on the x-axis, y is 0. So if I said the y-intercept is 2, you actually know a point. It's 0, 2, because on the y-axis, x is 0. Okay? So how do we find the intercepts? Well, graphically, if you have a graph in front of you and it's really easy to read the intercept, sometimes it's not as easy, then you can just read it off the graph, right? So here, for example, the x-intercept is -4. Here, the y-intercept is -2.
Please excuse this interruption. Working on our way now through grade 12. Starting, we're going to do teachers' last names, A through F, as inference. Any grade 12 students, those classes, if you need textbooks, can you please make your way to the book room? That's grade 12, teachers with last names, A through F.
Okay. If you have a table of values, these things that we starred above are really important, right? If you want to know the Y-intercept, for example, let's start with that. Which coordinate do we know when you're on the Y-intercept, the Y-axis? If you're on the Y-axis, what do you know? X is 0. So if you're looking at your table of values, you want to say, okay, where is X 0? Right there. That's the Y-intercept. Okay? If you're on the Y-axis, horizontally, you haven't gone anywhere. You're at 0. And then if you want to know the X-intercept, what value do you know on the X-axis? Y is 0. So, oh, sorry, the Y-intercept, my bad, is not 0. The Y-intercept is -1. Yeah, but on the X-axis, Y is 0. So actually, we have two X-intercepts because there's 2 points where Y is 0. And so these are the X-intercepts, 1 and 3. Okay? Calculator. So in fact, I think what I'm going to do is do all the stuff on the calculator at the end. So we'll talk about intercepts. We'll also talk about max-min points at the end as well. Let's talk about in factored form. So when you're looking at a quadratic, this is, for example, a quadratic function. There's a couple of different ways, and in fact, polynomials in general, that you can write them out. You can just write them expanded, where all the brackets have been multiplied out, or you can write them factored, okay? And both have their advantages. So this specific one has been written in factored form. If we were to expand it out, we would get something that looked like ax squared plus bx plus c, which you guys hopefully will be familiar with because you would have looked at it in whatever Math 20 course you would have seen, okay? But a lot of them we can factor as well. In factored form, we actually have information about our specifically X-intercepts, okay? And the reason is that we have to remember that on the X-axis, Y is 0. So if you want to find the X-intercepts, you're going to plug in Y equals 0. And for the Y-intercept, you're going to plug in X equals 0. Okay? Let's actually start with the Y-intercept because I think that'll be easier. On the Y-axis, X is 0. So if we have this equation over here, we know that this value and this value, those are both 0. So to get the Y-intercept, we just need to plug in a 0 for all of the x's, like a substitution. 0 plus 1 times 0 minus 2. And this can just be evaluated. Okay? So y equals -2, 0 plus 1 is times 1, and 0 minus 2 is times -2. And that is -2 times 1 times -2, y equals 4. Okay? Now this one was relatively easy because y is already isolated. So we just plug in a value for x, which is 0, and then evaluate it. What is that equal to? The other scenario is not quite as straightforward because here we're going to plug in a 0 for y. So this equation is going to become 0 equals -2 times x plus 1 times x minus 2. And we have to solve this. Okay. Now, to figure out what value of x would essentially make the left side 0. You kind of have to think along these lines. On the right side, we are multiplying three things together. We're multiplying -2, x plus 1, and x minus 2. If you multiply a bunch of stuff together and the answer is 0, what do you know about one of those things? Yep. Yeah. One of them has to be 0. It's the only way for these three things multiplied together to get 0. If these are all non-zero values, the left side wouldn't be 0. It would be something else. So how do we figure out what value of x would make the left side 0? Well, firstly, this factor of -2 is always equal to -2. So that will never equal 0. One of these two could equal 0, though, depending on the value of x. So either x plus 1 equals 0, or x minus 2 equals 0. Has to be one of the two. If x plus 1 equals 0, what value of x makes that true? Something plus 1 is 0. What does the something have to be? -1. Yeah. Right? And actually, to solve this, you could just subtract 1 from both sides. Okay? If x minus 2 equals 0, what value of x makes that true? 2, right? 2 minus 2 equals 0. And again, you could just add 2 to both sides. And that cancels, right? So you get x equals 2. So these are the two x-intercepts. Okay? Now, there are shortcuts, and many of you guys will probably start to remember those, right? So if you have x plus 1 as a factor, the x-intercept is going to be -1. If you have x minus 2, the x-intercept is going to be +2. You can get into some trouble there, though, because sometimes if you have a factor of like 2x plus 1, it's not going to be -1 because the coefficient of x is not 1 as well. Okay, so always revert to this if you get confused, right? Set the whole factor equal to 0, solve for x. Okay, questions? All right, so I'm going to get you guys to just do these three. And then we'll do all of the calculator stuff at the end, because I also want to talk about max-min values. Okay, so do A, B, and D, and we will reconvene in a couple minutes. Hi. So if you have your calculator with you, please take it out. I have a Casio and I have a TI on here. I just want to make this a little bigger. Okay, so here's the Casio. I think what I'm going to do is do these maybe one at a time. Just by show of hands, how many people have a TI calculator? How many people have a Casio? Wow. Oh, I'm surprised. Okay, it's funny. In grade 10, a lot of more people are getting Casios. Okay, well then maybe I'll start with the TI. Okay, so on the TI, whenever you want to graph anything, let me just make this bigger, you're going to go to y equals. And if anything is in there, just clear it out the way. And you are, in this case, we want to look at maximum and minimum points. And actually, before we get into calculator stuff, I should talk about max-min points, or sometimes they are also called turning points. Okay? A maximum and a minimum point is something like this. This would be a maximum point because it comes to a top. This would be a minimum point because it's kind of the bottom of this piece of the function. Okay? There are two types of max-min points. One of them is an absolute maximum or minimum, and the other one is a local maximum or minimum. Both of these are actually local, okay? Because they are not the absolute minimum value of the function or the absolute maximum value of the function. And the reason for that is, for example, if you look at this arrow, this goes up forever. So like the maximum y value here is infinity. So we can't say that this is a maximum value of the function. However, locally, to the points around it, this is a maximum point. It's a maximum value. And similarly, this we can't see as the minimum value of the function because there's an arrow going down forever. So the minimum value would be negative infinity. Okay? But locally, again, it is a minimum point. Okay? They are also sometimes called turning points because this would be the point where the function turns, in this case, from increasing now to decreasing, or over here from decreasing to increasing. Okay? How do we find them on a calculator? Well, we're going to use this example, negative 4x cubed minus 3x squared. Okay, so go to y1 if you have a TI. Negative 4, your variable buttons here, x cubed, power 3. And then, what is it? Hold on, I'm going to open up. It is minus 3x squared plus 6x plus 2. Minus 3x squared plus 6x plus 2. Okay? Now, what I like to do before I hit graph, if I don't know what the context is, and we'll start to talk about contexts probably towards the end of this week or into next week, then I like to go to the zoom button up here and hit number 6 for standard. And what that does is it sets my window for both x and y from negative 10 to 10. And then if I need to adjust from there, I will. So I'm going to hit 6. And actually, in this case, I can see everything that I need to see. Because what I really want to be able to see when I'm graphing something is all the intercepts and all the max-min points. And we can see all of that within this picture. Okay? So I've got, it looks like 1, 2, 3 X-intercepts. Here's my Y-intercept. There's a local max. There's a local min. Okay? When you are using the calculator to complete work, you should still show your work there. And here's how you were expected to do it. Okay? So what you're going to do is you're going to draw like a little box to represent what you see. And in that box, you're going to do a rough sketch of the graph. So it doesn't have to be perfect, but you should kind of like have the intercepts in the right place, for example. So let's see. Oh, that's the wrong calculator. Okay, so it goes down and then up, and it looks like the second x-intercept is on the negative side, and then down again. Okay, so looks like this. Okay, so I can see what I see on my screen. The other thing that's important to include, because somebody else is reading this, so kind of the goal is that you want them to be able to recreate what you've done. So one thing you need to say is what function you put in, right? So here what we put in was y1 equals negative 4x cubed minus 3x squared plus 6x plus 2. Okay? The other thing that's important to tell people is what your window settings were. So along the bottom, you should put 2 square brackets. And what you're going to put in each bracket is 3 numbers: x-min, x-max, x-scale, y-min, y-max, y-scale. Okay? So this went from negative 10 to 10. And I believe the scale is 1. Right? You can check that out, though, by, you can always go to, whoops, wrong calculator, to the window button, and it will tell you x-min, x-max, x-scale. Scale is essentially how much each little tick along the axis is worth. Right? So each tick in this case is worth 1 unit. Okay? And then once you do that, you can start to figure out the information that we want to know. So let's start out first with the max-min values. On the TI, everything that you're going to want to find out about a graph is under this calc menu at the top. So you have to hit second and then the trace button. Okay? Now for max and min, it hopefully should be pretty obvious which you need to select off this menu. If you're looking for a min value, you want to select 3. If you're looking for a max, you want to select 4. Okay? So let's start with the min point. Okay, now the min point is over here. It's going to ask you for a left bound and a right bound. If it's over here, left of it is this way. So you want to bring the cursor somewhere over here. Okay, that's the left of the minimum point. And hit enter. And then it's going to ask you for a right bound. And you're going to do the same thing. You're going to move it to the right and hit enter. And it's going to ask, do you want to guess now? And always just hit enter again. And you can see that the minimum value is basically -1, -3. Okay? So this point is, and if you have a Casio, don't worry, I'll go through this on there as well. Okay? If you want to know the max value, then you're just going to hit second, trace again to get to that calc menu, and you're going to go to number 4. And again, you have to go to the left and the right. Now, here's the max one. So the left is kind of over here, and the right is over here. You got to know your lefts from rights for these types of things. And hit enter, and then go to the right and hit enter. And yeah, I want it to guess. And that point basically is 0.5. 3.75. Sometimes it'll do this sort of thing where it has a decimal that goes on for a long time, but you can see what the value is going to be. That's usually because the calculators aren't perfect. There's like pixelation and stuff. Honestly, I'm not the best person to ask about why, but the value is 0.5, 3.75. I don't know about hardware on TI calculators. So that's that one. Okay, so that's max-mins. To get the intercepts, well, what you're going to select depends on whether you want an X or a Y-intercept. For the Y-intercept, again, you have to go to that menu. You're going to hit number 1 for value. And what this allows you to do is put in whatever X value you want, and it'll tell you what the Y value is. Well, if we're on the Y-axis, what's our X value? 0. So you're going to enter in X equals 0. And you can see that Y equals 2. Okay, so I'll put that in as well. To get the X-intercepts, I'm going to go to that same menu, and I'm going to select number 2 for 0, because an X-intercept is also sometimes called the 0 of the function, or sometimes it's called a root as well. It's called the 0 of the function because it's the value of X when the function, the Y-axis, is 0. Okay? Now in this case, it's going to ask you for a left bound, right bound guess again. So you kind of have to do these one at a time. Here's the first one, there's the second, there's the third. We got to do it 3 times. Okay, so I'm not going to do it actually all 3 on this calculator because I want to pull out the Casio as well. But for this particular 0, this over here is to the left of it. So I'm going to hit enter. And here is the right. Enter. And then I'm going to guess, and that is to the nearest hundredth, let's say, negative 1.520.
Can I have grade 12 teachers with last names M through P? Can you please make your way to the book room, room 237, grade 12.
Okay, so if you guys need to get books, you guys can go do that now. Okay, it's just down the hall. You don't need to take your stuff. Leave your stuff. You're not going to be that long. Okay? To get the rest of them, I am going to bring up the Casio. Are the Casio people still here? Sweet. All right. Let's do it. Casio is way easier, actually. So to graph stuff on the Casio, you need to go to Menu, if it's not up already, and select Graph. Okay? And if anything is in there, just delete it. That's F2. Yes, I want to delete it. And I'm going to delete this as well. F2. Yes. Okay, and then I'm going to enter in the same thing. So it was -4. Here's my X button, X cubed. And then it was -3x squared plus 6x plus 2. Okay, and I'm going to hit enter. And once you hit enter, you'll be able to draw it. And that's right over here, F6. So you're going to select draw. And it looks like I can't see that maximum point. So I need to adjust my window a little bit. I need to see like a higher y value up here. So I'm going to go to V window, F3. And I'm just going to go down to my y max. And maybe I'll make that 6. And I'll hit enter. Okay, and then it'll come back to here. I'm going to hit draw again. And now I can see what I need to see. Okay? Now, for the Casio, everything is under G-solve, which is F5. And if you want to find a maximum, you're going to hit F2. And it just gives you the point. You don't have to do any left bound, right bound, nothing. Just gives you the point. Okay, so there's the point. We saw that on the TI. It's the same thing. If you want to find the minimum, hit G-solve again. And you hit that. And it gives you -1, -3. Okay? And hit G-solve again. If you want the Y-intercept, you're going to hit F4. Gives you the Y-intercept. And if you want to know the X-intercept on these calculators, they're called roots. So you're going to hit G-solve, and you're going to hit F1 for root. And this is kind of nice because here it gives you the first one. So that's the one we saw in the TI. But for all the other ones, you don't actually have to do it over and over again. You just hit the right arrow, and it gives you the next one. So that's -0.31. We'll remember that. Actually, I'm not going to remember it. So this is -0.310. And then this point is, move it over again, 1.080. Probably would have been better if I had maybe done all of this, the points off to the side, because my graph is looking a little crowded now. But essentially, that's how you use both calculators to figure out information. Now, I can tell you a pitfall that tons of people in this course fall into, particularly those who have TIs. What they do is instead of going to that calc menu, they use the trace button. And they go back and forth, and they're like, OK, well, the minimum is like about -1.01, 2.97 or whatever. OK? You will get that wrong. Do not use the trace button to get information, ever. It has to be exact. Yes, it can give you a ballpark, but you will not get credit for that. Okay? So please remember that. Do not use the trace button to figure out information. Okay? Any questions here? All right, so I am going to end off today. What I'd like you guys to do is, for homework, try these two on your graphing calculator. See if you can find the X-intercepts as well. Okay? Now, actually, so I'm going to sign off and end the video. We're going to start actually talking about polynomial functions tomorrow.